students, welcome back to another day, and we want to quickly look at a topic in mathematics this morning. And what we have this morning is mensuration. You know, mensuration is very, very large, but within this context, we are going to try as possible best to try, or as much as possible, to reduce it to the barest minimum that we can take. So, when we are talking about mensuration, what are we actually talking about? It is actually the process, as you have it here, of measuring or calculating. The process of measuring, when you are trying to measure, when you are trying to calculate, maybe you are trying to look at the length, you want to measure the length, you want to calculate the length, you are trying to look at area, you want to measure, you want to calculate, you are trying to look at volume. All these, the process of you now trying to measure it, calculate the length, the area or volume of a geometrical shape, then we go, or we are talking about mensuration. So, if we look at what we have today, we have some shapes on the board, some plain shapes on the board. This shape, if you look at it very well, it's an example of a rectangle. And we may not have enough time to go about all these, but with this area, we're going to limit what we are doing here. Now, rectangle, when we are talking about area of a rectangle, it's simply length. Area of a rectangle is what? Length times breadth. On this context, we are going to stop there. Then let's look at this other shape here. If you look at this very well, this line is parallel to this, while this is parallel to this. Now, the question now is, what are parallel lines? They are lines that cannot meet no matter the extent you extend the line to. So the extent you take it to, they can never meet. If you want to continue with this, you have a very long shape that they will not meet. So this is an example of a parallelogram. So on our parallelogram, you know, we have the distance from the base to the top. That gives us the height. You can call it height, you can call it altitude. Now, for area of a parallelogram, that will give us what? Base times height. That is the only thing that is required from us when we are dealing with area of a parallelogram, when angles are not involved. But that of angles can come maybe in our subsequent lessons. Now, but we are not trying to look at angles now. We only want to quickly look at the formula for calculating just the area of a parallelogram, the base, the bottom side, and the height, the distance from this to this point. Then we also have another one here, which is triangle. We have our what? Triangle. Of course, we know. What makes this a triangle? This is a triangle because it has three angles, triangles, three angles. Now, this point where this line meets, this point is called the vertex. We are not trying to look at angle per se. I mean, we are not trying to look at the properties, but I just want to chip in that. If we want to calculate for the area of triangle, the formula is simply half times base times height, which is regarded as half base times height. So, coming down to this, where angle is not involved, when angle is involved, we may extend this formula. This is also another example, or a good example of trapezium. It could be two of these or one part. So, this is our word trapezium. I'm trying to look at the formula for calculating trapezium. The formula for calculating area of trapezium is simply half a plus b times height. The parallel side is the A. You could take this to be A, and this is our what? B. This is our A, this is our B. The top side is the top parallel line is the A, and the bottom is the B. So formula for calculating it is simply half times this, into this plus this into H. Then we have another one again here, a circle. From our center to any point of a circle is radius. But the line that divides it into two equal halves is our diameter. But we are not trying to look at the properties as I said before. We want to quickly look at the area. Formula for calculating area of a circle is simply pi radius square. Pi radius square. Then, if we are also looking at perimeter, perimeter could be the distance around a shape. So if we want to look for the perimeter of this shape, is this, whatever we have here, plus this, plus this, plus this, summation of all the sides of any of this shape. In circle, most times you may not see the word perimeter. The distance around the circle, most times you see it as circumference. Now, the formula for this, for circumference, is simply 2 pi radius. But for area, formula for calculating area for circle is pi radius square. Then we come to the last which we have here. We said this is a circle. Then we come to square. I'm not saying that these are the only plane shapes that we have, but these are the ones we can take for now. Square, if you look at it very well, I can call this my first side, and square, one of the properties of a square is that the four sides are equal. Hence, I indicated to show that they are equal. So if you want to go for area of a square, it's simply side times side, which is what? Side square. Now, we have an example here that we want to quickly look at. In this example, we are told, or we are asked, what is the area of the shape? This shape, the area, that is number 1. 2, we are also asked to find its perimeter. Now, let's quickly look at it. Let's quickly look at our area. We want to quickly look at the area of this shape. We are told that the distance from here to this place is 8. And here is 9. If here is 9, automatically this part is 9. And from our question, we have 2 here, we have 3. We are told that the distance from here to this place is 2. So you know that the distance from here to this place is the same thing from here to this point, which is 9. If we remove 2, that means from here to this place will be 7, here to this place will be 7. Are you getting me? Because 7 plus 2 will give me 9. The distance from here to this place is the same thing as this. Now we go again to look at it. 1 is missing, this point. We don't know what is here. And we know that from here, which is from here, to this point, which is this point, is 8. Isn't it? Yes. We have 8. And if we take here 3. From here to this place, 2. 3 plus 2 gives us 5. What do we now get to make up 8? If you remove 5 from 8, you have what? 3. So that 3 plus 3 plus 2 gives us 8. The total here. So that means this point is 3. I think we have been able to get all the sides. Then we can now proceed to the first question, the area. This shape, if you look at it very well, we just have to divide it into different shapes. We can decide to cut it like this. We can decide to cut, if we cut it like this, we're going to be having 1, 2, 3. We can decide to cut it this way, so that we have 1, 2, 3. Whichever way you go, you get your answer. I will suggest we go this way. If we go this way, we're going to be having something like this. We're going to be having something like this. True of us? True. We just cut it. Remember, here is what? 8. The distance from here to this place is 2, so here is 2. Are you with me? Okay. Now everything here is supposed to be 9. We have removed 2, which is 7. So this is also 7. Remember, this part is what? 3, and here is what? 2. We can call this one A, we can call this one B, we can call this one C. So let's start with area A. If you look at it very well, what is the name of this shape? Let's travel to what we have here. It is what? Rectangle. And formula for calculating area of a rectangle is length times breadth. Now, what is our length in area A? The longest side. Length is the longest side of an object. So we have 8 times what? 2. 8 times 2 gives us what? 16. Remember, we're talking about area. It's going to be centimeter square because this unit here is centimeter. Then we look at what? Area B. B is also what? A rectangle, and it's going to be length times breadth. Now, going by this, our length is what? 7, and our breadth is what? 3. If you multiply 7 by 3, 7 in 3 places or 3 in 7 places, you have what? 21 cm what? Square. If you omit your square, then it's wrong, because our area must go with what? Square. Then we go to the third one, because we have 3 shapes actually after dividing. So we have area C. It's also a rectangle, which will give us what? Length times breadth. What is our length? 7, because it's the longest side. Times, what is the breadth? 2. 7 in 2 places or 2 in 7 places will give us what? 14 cm squared. Remember, the shape was not divided. We're given a single shape. But now, for us to be able to solve this easily, we decide to divide it. Now we have to bring it back to 1. So we have what? Sum of what? Summation of areas. So if we go by the summation, we have area A plus area B plus what? Area C. Area A is 16 cm squared. Area B is 21 cm squared. And area C is 14 cm squared. Trying to bring this 16 plus 21, you go by this. If you cannot do your easily summation, you can go this way, or you just say 6, the units now, 6, 1, 4. That will give you 11. Put down 1, carry as case may be, or you go this way. This plus this plus this will give us what? 11. You carry 1. 2 plus 1, 3. 3 plus 1, 4. 4 plus 1, that you carried 5. So we have the total. Therefore, our area will now give us what? 51 centimeter squared. That gives us our area. Then we now quickly do the big part, which is perimeter. Remember, I told you when we started, we'll be right back.